Good morning, students. Let's begin our chapter Light. Hope you have understood till the image formation by concave mirror and convex mirror. Hope you also have understood the rules, and one day I'll take your test. I hope if there is any problem, you please send me or ask me the question. I'll clear your doubt. So students, let's begin. Today we will study new Cartesian sign convention and the mirror formula. New Cartesian sign convention. Again there are some rules. That means which type of rules? Sign is assigned to some of the physical quantity. Sign means, then again you will think that which type of sign? Only the nature of the sign, that is negative or positive, which is very much important whenever you will solve the numerical of light. So this sign is assigned to some of the physical quantity which is used in the formation of image or in the measurement, whatever is used in ray diagram. So what are that physical quantity? First let us try to understand. U denotes object distance. This is object distance. V denote image distance. Image distance. F, it denotes focal length. Focal length. So students, whenever we have studied our ray diagram, then we have studied that where we are keeping the U, that means where is the distance of object, what is the distance of object, what we are getting the image, which type of image, where, what is the position of the image, and focal length. Focus is that adjusted one, what is the focal length. These are the physical quantity. So U is measured in centimeter, SI unit. Same V is measured in centimeter and F is measured in centimeter. By knowing this thing, if I'll say you calculate, I am giving you numerical. So how you will do this? We don't know that where we will put minus or where we will put plus. So that only the sign is assigned, that sign convention is assigned to this physical quantity, and then when there is one mirror formula, by using that sign, and very easily you will calculate it. So let us see how we are assigning the sign. So first of all, I will discuss with you today concave mirror. Concave mirror. Students, I have drawn this concave mirror. Then we will draw the principal axis. Draw the principal axis. This is principal axis. Focus and center of curvature, I think you have understood how to take it. Whatever, again I am repeating this one. Whatever distance from pole to focus, same distance from focus to center of curvature. So whenever you will draw, please measure it. Now, only one thing you remember, according to physics, the distance which is measured in the direction of incident ray is always positive. The distance which is measured in the direction of incident ray which is always positive. So here you will see, if for example I am taking, if we are keeping object beyond C, naturally the incident ray will be parallel to the principal axis. Then again students, you will think that then from where we will measure, how we will measure. No problem. I hope you know the graph of maths. If graph of maths is just in your brain always, very easily you will do. I am showing you this graph. See, this is the origin O. If I say you measure x is equal to 2 centimeter. 2 centimeter. So very easily students, you are knowing this is positive x-axis, this is negative x-axis, this is positive y-axis, this is negative y-axis. If you have measured 2 centimeter and that is positive plus 2 centimeter, so we are measuring 1, 2, this is 2 centimeter, x is equal to 2 centimeter. Means we have started from some origin. In case of mirror, the origin is pole. Any of the distance you will measure, you start measuring from pole. In your scale, whatever be the zero, that should lie on the pole. Now it is clear? So check it. First of all, U, object distance, U. U is always kept at the reflecting side of the mirror. If we keep the U at the polished side, no image will form. So, U is always kept at reflecting side of the mirror. That means you are measuring U from pole to the distance of the object, that means this distance. See, we are going opposite of incident ray. Incident ray is going in this direction, forward direction, and when you will measure this object distance from pole to object, we will go in backward direction. So you see, we are in x-axis, we are coming in this direction, and this direction is negative. This direction is negative. So what will be the U? U will always be negative. Either it is concave mirror or convex mirror, or when we will study refraction, that is the lens, U is always negative. Then come for V. V, students, we have studied image of two types, real image and virtual image. Virtual image. Now you see, real image, remember, I am repeating, when two reflected or refracted ray directly meet at a point, and that two reflected or refracted ray is directly meeting in front of reflecting surface. Remember the ray diagram, you will find that the two reflected or refracted ray is directly meeting in front of reflected surface. So, real image, suppose when object is beyond C, your image is forming between C and F. So, this distance. Now you see from where you start measuring pole and pole to this image. You are also coming in this direction, but the incident ray is in forward direction. We are coming backward direction. So it is negative. If you will plot this in graph, it is negative. So for real image, sign will be negative. Then what happens for virtual image? Virtual image is forming at the polished side of the mirror. We have done last class. Virtual image is forming at the polished side of the mirror anywhere in this side. So you will see from pole to image we are going in this direction. So forward direction, same direction as the incident ray. So if you will go in forward direction as the incident ray is going, it is positive x-axis. So it is positive. So what we will get? Virtual image is positive. Hope you have understood. Then come for focal length for concave mirror. Focal length for concave mirror. What is focal length? The distance between the pole and focus. From where we are start measuring? From pole. Our origin is pole. So from pole to focus, again we are going opposite direction to the incident ray. That means we are coming in this direction. So it is negative. It is negative. So focus is negative for concave mirror. Students, sometimes it is happening that by chance we are forgetting the this rules how we are measuring. Then what you will do? Shortcut method I am telling you. Just draw the mirror principal axis and plot the graph. Paste the, imagine, don't show it by written. Just you imagine that I am pasting the graph like this. Like this. This graph is just pasted on this so that origin will lie on the pole. And now very easily you will find out which one is negative, which one is positive. Again student, one more thing. Height h, height of the object. H represent height of object or size of object. Height of object we are always keeping on the principal axis, somewhere this or somewhere we are keeping like this. That means it is going upwards. So if you will keep on x-axis, just see it is positive y-axis, positive y-axis. So height of the object will always be positive. It is going in positive directions. Then one more thing you will come, h dash. Size of object or height of object, you can write h or even you can write o, no problem. For h dash or somewhere in the book you will find it is written I, no problem. So h dash means height of the or size of the image. Size of the image, again two cases arises. Real image, for real image it is always inverted downwards. So if you will keep in axis, you will find that it is downwards, means it is downwards. So negative y-axis. So for this case, height of the image will be negative, and for virtual it is on the principal axis like this. So it is positive. So it is positive. So for concave mirror, real and inverted, the sign assigned is negative, and for virtual is always erect. The sign assigned is always positive for the case of concave mirror. So students, hope you have understood this one. If you have understood this one, then one more thing. Then what is the relation between U, V, F? That relation is known as mirror formula. That relation is known as mirror formula. So what is the relation? 1 by F is equal to 1 by V plus 1 by U. For both the mirror, you will use this formula. But students, I have taught you only the sign convention for concave mirror. Then what will be the sign convention for convex mirror? Just again, I am showing you. It's very easy. I have drawn this convex mirror. This is the convex mirror. I have drawn the principal axis, and this is the pole from where we are measuring according to physics. If we are measuring the distance in the direction of incident ray, then always it is positive. Or if you will forget, paste this graph positive and negative, easily you can able to answer. So you see here, for convex mirror, U is always kept at the side of reflecting surface, so U is negative for convex mirror. And what about V? In convex mirror, V is always virtual and erect. So if it is virtual and erect, so it is positive. For convex mirror, image is forming at the side of polished surface. So from pole to this image, we are measuring the distance, so that means it is in the same direction of incident ray, so it is positive. Only the differences is focal length. What is the focal length for this? For convex mirror, focal length is in the same direction as the incident ray, so it is positive. Anywhere F is this side, so you start measuring from pole to focus, so you will see this is positive. So this because it is in the same direction of the incident ray, and when you will compare with graph, you will find that again you see it is going to positive x-axis. So only the difference for convex mirror, F is positive, and for concave mirror, F is negative. So students, till here you will practice, and then next class we will start solving the numerical. Okay.